numerical on knuckle joint. So I'm going to cover another numerical on knuckle joint. So just I'll read and write the given data from my end so that it will clear from your side also. Two rods required to withstand tensile force of 25 kilonewton. P is equal to 25 into 10 raised to 3. It is in Newton. Are connected by means of knuckle joint. The two rods and pin are made up of steel. Correct? Two rods and pin are made up of steel. SYT, ultimate yield strength in tension 380 Newton per mm square. Then the yield strength in compression is twice of yield strength in tension. So I'll write SYC is twice of SYT. That is very important. The yield strength in shear is 50% of tensile. Of course, yield strength in shear is always 50. We have take always 0.5 of SYT. So no issue. The factor of safety is 6. FOS 6. Determine the diameter of rod on the basis of tensile. So we'll have to calculate diameter of rod means D question mark. Determine diameter of pin on the basis of bending failure. Particularly they have mentioned use only bending. So D is equal to question mark. Then assume outside diameter of eye or fork as twice of pin diameter. Very important. Twice of pin diameter. Assume outside diameter is twice of pin diameter. I have written the condition. DO is equal to twice of D. The thickness of each eye of the fork end is 75% of rod diameter. 75% of rod diameter. This is for fork. So fork is having A. Correct? How much? 0.75 times diameter of rod. Then while thickness of eye, that is B, 125% of rod diameter. So B is 1.25 times capital D. All the conditions we have mentioned. Assume these proportion and calculate shear stress in pin, compressive stress in pin and eye, compressive stress in pin and fork, tensile stress in eye, shear stress in eye, tensile stress in fork, shear stress in fork. So one by one we need to calculate, but before that we'll have to write the given data, and that I have written, and we are going to calculate one by one. So after learning this, after understanding the statement, I have written this given data. Now we'll move toward the step number 1, permissible stresses. Permissible stresses. Now permissible stresses we'll have to calculate. First, tensile, that is SYT by factor of safety. So we know it is how much? 380 divided by factor of safety 6. So it will gives me the tensile is around 63.33 Newton per mm square. Then crushing, SYC by factor of safety. Now we'll have to check whether the relation is given. They have mentioned twice of SYT. So I will have to write twice of SYT. In case of yield strength in compression, so factor of safety is 6. So by putting the value, I'll get the crushing stress 126.67 Newton per mm square. Correct? And lastly, shear 0.5 of SYT. The condition they have given, see, 50% of tensile yield strength. So I have written SYT by factor of safety. We know by putting this we'll have to get 31.67 Newton per mm square. Correct? So these are the permissible stresses which we have calculated according to the given data. Now we'll move toward the step number 2. So step number 2 is indicate what? Diameter of rod. Diameter of rod. So it is small d. diameter of rod capital D. It is capital D. So diameter of rod, for that we know tensile stress is equal to force by area. So therefore diameter is equal to square root of 4p by pi into sigma t. Is that correct? Is that clear? Now we'll have to use 1 by 1. It is square root of 4 into 25 power pulling force, we can say tensile force. It is not power, pulling force, 10 raised to 3 divided by pi into sigma t 63.36. So through which I'll get the diameter which they have asked, that will be the first diameter of a rod. It is 22.4, so I'll say it is 25 mm. Is that clear? So they have asked firstly this. Correct. Now they have asking for diameter of pin. So we'll move toward the pin. Before that, we'll have to maintain our step. Step number 3, empirical relations. We'll have to maintain the sequence, empirical relations. So first empirical relation, we'll have to use the things, that is A is equal to 0.75 times D. So D is known, 25. So 0.75 into 25 will gives me the value of A is 20 mm. And for B they have mentioned 1.25 times they have given. See here D, so I'll get the B is 35 mm. After that we have to get the D. D is nothing but diameter, and for that diameter we need to calculate this diameter of pin. Correct? Now see, step number 3, calculate diameter of pin. This is for pin. So we'll have to use the equation D is equal to cube root of 32 divided by pi into sigma B into P by 2 in bracket B by 4 plus A by 3. So all the values which we know, so sigma B will have to take tensile, that is 63.33, and B value we have calculated, A value also we have calculated, and through which we'll get the diameter through bending. Diameter through bending, they have asked diameter through bending. Here I have written bending. So diameter is around 35 mm. So this is second calculation which they have asked. We have calculated. Now one by one, as per their requirement, we'll have to move towards the step number 4. Step number 4 is indicate, as per our sequence, design of eye. Design of eye, or it means we'll have to checking of stresses. Checking of stresses. Correct? So while checking of stresses, we'll have to use firstly tensile force by area, B into DO minus T. Correct? P is nothing but it is around 25 into 10 raised to 3 divided by B's value we have calculated 35 into DO also we have calculated DO, twice of D. It is directly twice of D, and we are having diameter is 35, that is 70 minus 35. So through which we'll get the tensile stress occur in case of I, that is sigma T, that is tensile, will be occur. Tensile काढलंच नाही की यांनी
2 pi nt by 1000
आणि आन्सर
टेन्शन तुम्हाला परत कॅल्क्युलेट करावं लागेल
35 आणि 35. सो टेन्साईल ओके. शेअर किती काढलाय? 20. ओके. Now see here, tensile 20.41 Newton per mm square. Now this value is less than tensile how much? 63.31. Therefore design is safe. Is that clear? So likewise we have calculate first is tensile, then we'll have to use crushing, that is P by B into D. So P is 25 into 10 raised to 3 divided by B is nothing but we have calculated 35 and D is nothing but it is also 35. So through which for the crushing failure or crushing shear stress will occur in case of I, that is in case of I again 20.41 Newton per mm square, correct? And this is again design is safe because 20.41 is less than permissible, that is 126.67. Therefore design is safe. Now in case of the shear, tau is equal to same P by B into DO minus D. So I'll get the same as like a tensile, that is 20.41 Newton per mm square. So here also design is safe. Is that clear? Now after that we'll have to calculate the step number 5. It is related to fork. Design is related to fork. Now in case of fork, I told you the three equation which we have to calculate. Sigma T is nothing but P by twice of A into DO minus D. Correct? All the values we know. A value we have calculated, that is 20. So just put the values and through which we'll get the tensile again for case of the fork, that is 17.86 Newton per mm square. It is again, we'll have to check with the tensile 63. So this is less than permissible, therefore design is safe. Correct? Now in case of the crushing, I will have to write P by instead of B to A into D. So by putting all the values, it will gives me 17.86 Newton per mm square. This is again safe because it is less than 126. And lastly, shear is equal to same as that of tensile 2A into DO minus D. It is equal to 17.86 Newton per mm square. Here is also design is safe. So I can say whichever be the parameter they want, as in a calculated one, we have calculated sequentially. So maintain sequence is very important. So firstly we have calculate the permissible stress, secondly empirical relation, thirdly we have used design of I and design of fork and checking of that, and we'll have to say the design is safe for the given problem statement. Thank you.